Hello, Mr. Claudia here. Today we're going to continue learning about motion and calculus, and this time we're going to be looking at the acceleration. Once again, if you've studied these in physics, you're going to find them familiar, but the way we solve the problems is very different in our calculus class. Acceleration is the instantaneous rate of change of velocity, or the rate of change at which your velocity changes. So acceleration as a function of time is the derivative of velocity, which was the derivative of position or displacement. So the acceleration then is the double derivative or second derivative of position. So if if position or displacement is where you are, the rate of change is how fast you're moving. The rate of change of your speed, so how fast your velocity is changing, that's acceleration. If you have an acceleration greater than 0, then the velocity is increasing. If you have an acceleration less than 0, then the object's velocity is decreasing. And if your acceleration is 0, the object's velocity is not changing. Just to kind of illustrate this with the dinosaur. So let's say it's stationary, and then it starts moving forward, and it's going faster and faster and faster and faster and faster. It's accelerating. Acceleration is what you feel when you're on a roller coaster or when you're going around a corner. In all cases, the velocity starts off, or is changing. In this case, it starts off with a small velocity, and by the end, he's going very fast. Similarly, if you have an acceleration less than 0, the object's velocity is decreasing. So if you can imagine the dinosaur moving very fast, and then it slows down and comes to a stop. His velocity is decreasing. Finally, if the object is not moving, then its acceleration is 0, but also if the dinosaur is moving at a constant speed, then the velocity is not changing. So again, the acceleration is 0. It's a bit more of a complicated concept than velocity, as we'll see in a few minutes. The units of velocity are meters per second. Okay, that's the unit of velocity. And then divided by time. So the units... Oh, sorry, this should say acceleration. Oh, that's a typo. How many years has that been there? Units of acceleration are usually then meters per second squared, we would say. Now, there's a tendency to think that acceleration is speeding up or slowing down. And you are right to a point. When acceleration and velocity have the same sign, the object is speeding up. When the velocity and acceleration have different signs, the object is slowing down. But it's not that simple, and it can get a little bit confusing because of this direction idea. So let's go through some different examples. If we compare the signs of these two things, we can figure out what the type of motion it is. And to do this, you can see the picture here of Vin Diesel, star of the Fast and Furious films. He knows all about acceleration because he drives cars a lot. So Vin Diesel, and I'll use my dinosaur to illustrate. Vin Diesel gets into his car, so it's at rest. He presses the gas pedal and accelerates forward. That means he starts moving faster, 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 faster. So the acceleration is forward, so we'll say, or sorry, the velocity, he's traveling forward, so it's positive. And the acceleration, he's also going forward acceleration. So because those two signs are the same, we would say he's speeding up. And no one would argue that Vin Diesel can really make those cars move fast. Speeds up. Now, let's say he's driving along, he's approaching a stoplight, so he presses the brake pedal and accelerates backwards. Well, think about this situation. He's moving really quickly, and then he slows down. So the velocity, well, he's moving forward. The speed is in the forward direction, so velocity is positive. But acceleration, well, he's actually accelerating backwards. Right? The velocity is going down, and he's actually kind of trying to accelerate in the opposite direction. So the acceleration is negative. So that's why this is the case of him slowing down. Okay, now next situation. A villain is driving toward Vin Diesel's stationary car. So there's our Vin Diesel, and there's some sort of villain driving toward him. Okay, so Vin Diesel panics. He puts the car in reverse and presses the gas pedal. So he starts moving backwards and then starts going backwards really fast, and the villain can't catch him. So in this case, his velocity is backwards and his acceleration is also backwards. So again, he's speeding up. So these are different because here he's speeding up in the positive direction, here he's speeding up in the negative direction. Then there is this fourth case. Vin Diesel wakes up and realizes his car is rolling backwards down a hill. So he's going like this. He quickly presses the gas to try to drive forward. So as he's going back down the hill, he puts on the gas, he's going, he slows down, he stops, and then he starts moving forward. So in this case, his velocity was negative. He was going down the hill, but he was trying to accelerate forwards. So what ends up happening is he was slowing down. And you can kind of imagine this, right? He's going down a hill. Let me make this a little bit more realistic. He's going down the hill, he's falling down the hill, he puts his foot on the gas, but then the car is still rolling down the hill, and then eventually slows down, and then he starts going up. But during that phase where he's going backwards and accelerating forward, he's slowing down. So that's why there can be a few different situations with acceleration. It can be a little confusing with the directions. Then finally we have this last situation. Vin Diesel is peacefully driving on the highway at a constant velocity. Doesn't normally do that, but in this case there's no acceleration. So that's an important thing to note. In this case he's driving peacefully forward. He could be driving peacefully backwards, but there's if he's at a constant velocity, then there is no acceleration. So hopefully that gives you an idea of what acceleration is. Let's do some examples. I think I already said it. Acceleration is the thing you feel on roller coasters, that change when you speed up or slow down. That's what makes roller coasters really fun. Okay, so a ball is thrown upward with an initial velocity of 24.5 meters per second. Its displacement is given by this function. Okay, find the ball's acceleration. Well, to find acceleration, first I need velocity. And velocity is the first derivative of displacement. So that would be 24.5 minus 2 times 4.9 is 9.8 t. And then acceleration will be the first derivative of velocity, so that'll be negative 9.8. And that would be meters per second squared. Let's just talk about this a little bit. And again, if you've taken physics, this is no surprise to you. But look how we didn't use one of your big five formulas. We actually used calculus. But let's talk about this. Oh, so sorry. Initially, is the ball speeding up or slowing down? Well, velocity at the beginning, v at 0, because we're talking about initially, so that's time equals 0. At v equals 0, my velocity is 24.5. At a equals 0, my acceleration is negative 9.8. So therefore, signs are different. So signs are different. Therefore, slowing down. To help illustrate this, I have the 3 graphs here. And this can be a confusing concept, what's happening originally. When you throw the ball, it's slowing down. But look at the motion of your ball. The ball is being thrown from the ground and it's being thrown upward. So it travels upward at the beginning, it reaches a max point, and then what goes up must come down. Gravity pulls it back down to Earth. Here is the matching graph showing the velocity. So here you see in this section, this is a positive velocity. Ball travels up, right? Because at the beginning, your velocity is positive. The ball is traveling in the positive direction, the upward direction, but the velocity is decreasing. So the ball is actually getting slower, and eventually when it reaches, so as it goes up, it's going slower, and eventually it reaches the top. At the top, that corresponds to a velocity of 0. So for a split second, the ball stops falling. It just is stationary. And then the velocity is negative. So this is a negative velocity. And at this point, v equals 0. Ball is stationary. For a split second. So this can be confusing. We have positive velocity, negative velocity, and a split second where it's not moving. And throughout the entire thing, the velocity or the acceleration is always the same. It's a constant acceleration. And this is an important thing that we should note, that, and it's kind of a TOK thing. All objects on Earth experience the same constant acceleration downward. And that's negative 9.8 meters per second squared. That's something that, that in physics we make a big deal about, but all objects accelerate at the same rate. So we all are, if you were to throw something off a bridge, or throw a bowling ball off a bridge, or throw a book off a bridge, they're all going to accelerate downward at negative 9.8 meters per second. I should technically put it down here. So that's why you have a constant acceleration. So even though this ball is going up, sometimes it's going down, it's still accelerating at the same rate. And that's why actually at the beginning it's slowing down as you throw it upward, but then after it reaches its max point, it starts speeding up and coming down. So that's right here you have a positive velocity and negative acceleration, slowing down. Here you have a negative velocity, negative acceleration, so it's speeding up. So, and then there's that a TOK idea, so you can impress your friends with your physics knowledge. And so just to go back to the initial question, initially the ball is at 0, you have a positive velocity, negative acceleration, so the ball is slowing down. So you've just thrown it, and it's actually going slower and slower and slower until it reaches that max point. Okay, hopefully we haven't said too much of that. Let's continue with our next and final long question here. A car moves according to this equation, and there's a displacement equation, for the first 10 seconds. T is between 0 and 10. Find the velocity and acceleration functions. Again, with these long questions, especially on an IB paper, the first few questions should be straightforward, and you can probably figure out without doing too much thinking. I mean, to find velocity, if you've been given displacement, is a derivative. To find acceleration is another derivative. So even with a long question like this on an exam, there should be a lot of free marks to pick up here. So this is going to be 6t squared minus 42t plus 60. And the acceleration is going to be the derivative of velocity, which is going to be 12t minus 42. That's that. That's so far so good. Okay, let's keep going. Part B. Find the average acceleration between t1 and t2. Now be careful, because a average, remember, average is not, in this case it's not dv dt, it's delta v over delta t. So it's actually v at 3 minus v at 1 over, what was it, time equals 3 over time minus time equals 1. So in this case we're using, if you think back to the rates of change lesson, average suggests we're not using calculus, we're actually using like our slope formula. Okay, so let me sub in these numbers. Oh, I gotta figure them out. What's v3? So much work. I'm gonna sub 3 into this expression, so 12 times 3 minus 42. Have I done that incorrectly? Yes, I have. Can I make it look like I did it correctly? 6 times 3 to the power of 2 minus 42 times 3 plus 60. That gives me, what's it, 9 times 6 minus 42 times 3 plus 60 should give me negative 12. That sounds good. And v at 1 is equal to 6 times 1 squared minus 42 times 1 plus 60. And that gives me 6 minus 42 plus 60, 24. Sounds good. So I'm just going to put that in a little bubble. So that means I have negative 12 minus 24 over 3 minus 1 So I get minus 36 over 2, so that gives me minus 18 meters per second squared. Again, if you want to think about this, the average acceleration then between 1 and 2 is negative. So the car is accelerating backwards between this time. Okay, so let's go to part C. Consider at time 3. Is the car speeding up or slowing down? Well, we just talked about this on the other side. To know if the car is speeding up or slowing down, I need to know what is v at 3, which we already figured out. It's up here, it's negative 12. And I need to know a at 3, the acceleration. What's the sign of that? I can sub that in, so 12 times 3 minus 42. That gives me 36 minus 42, which gives me negative 6. So, so the car is speeding up. Because the signs are the same. And just to be clear, the car is speeding up backwards. Right, in reverse, technically. So he's going backwards and it's accelerating backwards. That's that situation where Vin Diesel's trying to evade a villain. Okay, let's go to part D. Find when the car is moving forwards or backwards. Okay, so now we have to think a little bit. So this equation tells me where the car is. This tells me how the car is moving, the speed it's moving, and whether it's moving forward or backwards. Right, so I need to look at velocity if I want to know if the car is moving forwards or backwards. So this is like yesterday's question, part D. So we're just going to make a little note there. Recall, if your velocity is greater than 0, then your car is moving forward. And if your velocity is less than 0, then you're moving backwards. Just remember that. So this part of this question is decoding the fact that if you're asking for forward or backwards, you're looking at the velocity. And so what we need to do is take my velocity, 6t squared minus 42t plus 60, and we need to figure out where this function is positive or negative, right? Positive it's forward, negative it's backwards. The way we do that, we think back to our curve sketching lessons. We want to find the critical points by factoring. So I have 0 is equal to, well, let me factor out the 6, so I get t squared minus 7t plus 10. I can factor this and it becomes 6t, what is this, negative 2t minus 5. So now I have two critical points, I have t equals 2 and t equals 5. So if I want to know the sign of this function, I can make a sign diagram. And remember, this is very similar to the curve sketching. That's why we do, oops, my pencil or my pen. This is why we do this after the curve sketching unit. It has a lot in common with the curve sketching unit. The only thing here is that we only go from 0 to 10, and I have a 2 here, and I have a 5 here. So my number line doesn't go on forever. And now I need to write out all of my different intervals. So I had 1, 2, 3 intervals. So I have 1, 2. That'll do. Okay, now I'm just going to keep drawing my intervals. So I have interval between 0 and 2. Then I have from 2 to 5. Then I have from 5 to 10. Now, usually we don't have these endpoints, but time we know doesn't go negative, so you can't have a time less than 0. And we were told in the question that the time can't be any more than 10, so that's why I'm capping it at there. This is what we're showing here is the sign of v at t. We're showing the sign of the first derivative. Okay, and now let's write all of my different different factors. So I had a 6, I had a t minus 2, I had a t minus 5. I'm just gonna show that. Okay, let's go through these different factors. So the number 6 is always going to be positive. That's the sign of that is not up for debate. Okay, t minus 2. Well, if I choose a number that's less than 2, this is negative. Then these are going to be positive. If I choose a number that's between 0 and 2, this is going to be negative, negative, and this will be positive. 2 negative, so this will become positive. 1 negative, negative, positive. So now I have my result. I can put it up here. Between 0 and 2, the sign is positive, negative, and then positive between 5 and 10. Therefore, again, just like the curve sketching unit, the car is moving forward. It's positive between 0 and 2 seconds and 5 and 10 seconds. Just a note, remember you can't include 2 because we know it's stationary at 2. It's a transition point, so it's not included. But 0 is included because it's not a critical point. It's moving backwards between 2 and 5. Great. Okay, let's keep going. I need a separate sheet of paper. This is going to be 9.2b, page 3. Okay, what do we have now? Find when the car is moving forward or backwards. Okay. Find when the car has a positive or negative acceleration. Okay, well, there's my acceleration, so I need to know when is this positive and when is this negative. So I'm going to use the same strategy. So this question, question E, is the same sort of thing. It's kind of like finding concavity. It's kind of similar to our curve sketching unit once again. A at t is equal to 12t minus 42. So we have to find what I call the critical points in brackets, or the possible points of inflection. I've called them before too. So I'm going to set this equal to 0. I'm going to factor, so I end up with 2t minus 7 when I factor it. So therefore, if this is going to be equal to 0, I end up with 2t equals 7, so t is equal to 7 over 2, or 3.5. There's only one factor, there's only one correct answer. So now I can divide up my number line much like I did last time. So I have 0, 10, and 3.5 is my kind of, we call it the critical point in brackets, or the possible point of inflection. And this is a sign of AT, the sign diagram for AT. Now you could probably do this. Try completing the sign chart without a table. You might be able to do this without a table because it's not really super tough. Just need to think a little bit. If I choose a number as less than 3.5, say 1, and I sub that into my equation, I get 12 times 1 minus 42. So A at 1 is negative. And then if I choose a number greater than 3.5, say 5, I get 12 times 5 is 60, it's going to be positive. So you can sort of do that one because there's not a lot of factors to worry about. You can do it pretty quickly without all the fuss of a table. So therefore, once we have our sign diagram, we're actually done. We can say that there's a positive acceleration between 3.5 and 10, and there's a negative acceleration between 0 and 3.5. Again, there's a lot of parallels here to our curve sketching chapter. Let's go back, our last question, which is find when the car is speeding up or slowing down. Okay, well remember, speeding up or slowing down, you need to know both VT and AT. So what I'm actually going to do is just redraw the two sign diagrams here. And if I draw them kind of so they line up, I can compare them directly. So here's VT. It was, I had 2, 5. and it was plus minus plus, and then I have AT, which we just did. I'm going to draw this as well. So I have 10, 0, and then it was 3.5, so somewhere here. And this was minus and plus. So now you can get a sense. Remember, if the signs are the same, it's speeding up. If the signs are different, then it's slowing down. So therefore, the car is speeding up. With the same signs. Okay, when are the signs the same? Okay, so they're different here. Oh, they're the same for this brief period here between 2 and 3.5. They're both negative. And then between, they're different here, and then between 5 and 10. They're the same. They're plus. And therefore the car is slowing down. Different signs. That would be between 0 and 2. And this is negative, negative. This is plus, oh, between 3.5 and 5. There we go. So again, step by step, there's only 3 things to worry about here: displacement, velocity, and acceleration. The trick with these questions is decoding what they're asking. So our homework for tonight is page 229, number 1 to 4. And I'll just write it here, but it's not necessary to do it. Page 225, number 1 to 3, which is extra practice on velocity. And that's not necessarily, you don't necessarily have to do that, but if you want some extra practice. All right, good luck with that, and we'll see you next time.